So we continue our discussion looking at the body of an aeroplane. So obviously, engineers and scientists work together in the construction and manufacture of an aeroplane. So an aeroplane is a very heavy object that flies in the air. It's a machine that flies in the air. An aeroplane is meant to carry very huge masses together with its body. So there is need of making the body, or there is need of making the weight of an aeroplane as light as possible. So the suitable material or the suitable metal which was chosen to make the body of an aeroplane was aluminium. They went ahead and made an aeroplane out of aluminium. But however, aluminium has got its weak properties. Remember, every material have got strong properties as well as weak properties. The weak properties of aluminium is that it is soft. The second weak property of aluminium is it is not hard, and also it tears fast. The tearing that we are talking about is the actual tearing of tears like that. So a sheet of aluminium will easily tear. Right. Now, if we look at an aeroplane, when it is flying, it flies at a very high speed. There is a very strong force opposing the aeroplane, a force of wind opposing the direction of an aeroplane. And if we make an aeroplane out of pure aluminium, then our aeroplane is going to break into pieces due to the strong force that is acting against the direction of flying. Now, scientists came up with an idea of making an alloy out of aluminium and magnesium. So, aluminium plus magnesium, copper, and zinc. Right. So, in mixing aluminium with magnesium, aluminium with copper, aluminium with zinc, or in mixing all of these, they came up with a very good property which became light and hard. You must take note that lightness is already achieved by aluminium only, but hardness is not achieved by aluminium only. So the alloy of mixing aluminium and magnesium, or aluminium and copper, aluminium and zinc, achieved the property of hardness while maintaining the property of lightness. And then the body of an aeroplane, the ideal body of an aeroplane, was successfully made. In the same note, if we look at the manufacture of bridges, the construction of bridges, right? The most suitable material to construct a bridge is iron. But pure iron has got its weaknesses. Pure iron corrodes very easily. So the first weakness is that pure iron corrodes easily. So because pure iron corrodes easily, it is not suitable for the construction of bridges. So obviously the first bridges corroded easily and collapsed. And then scientists came up with an idea of making an alloy out of iron and carbon. So carbon and iron were mixed to come up with steel. So steel was made. Steel does not corrode easily. Steel is tough. Steel is hard. Those are the suitable properties that are desired in making bridges. Right. Another very good example of an alloy is bronze. So bronze is a mixture of tin and copper. So bronze is a mixture of tin and copper. So tin and copper were mixed to make bronze. Right. Tin on its own, the metal tin on its own, is not a good conductor of heat and electricity. Tin on its own will corrode. Tin on its own, in its pure substance, is very brittle. Then tin was mixed with copper to come up with bronze. So now this bronze has got properties of resisting corrosion, right, as well as improved properties of conducting heat and electricity. So bronze is an alloy that is used in manufacturing tools. Bronze is an alloy that is used in manufacturing military hardware like weapons, because bronze stays for a very long time without corrosion. So that's it on the topic of exploring our alloys. Of most importance, we must know that in chemistry, an alloy is a substance that is made out of more than one element, and one of the elements always has to be a metal. So when there is no metal in the alloy, then we cannot call that an alloy. And we must also remember that what was discovered first were pure metals. But the weak properties that pure metals possess are the reasons that gave birth to alloys. Thank you.